There is nothing more terrifying than a shipboard fire. At sea, there is no place to run and no fire department to come to the rescue. The potential for catastrophe creates the need for constant vigilance among the crew to prevent the loss of life, the damage to the ship, and the damage to the environment that can result from fire. Every seaman must pay constant attention to fire prevention and be capable of serving as an effective member of a fire response team. This program offers an overview of basic firefighting in accordance with Table 6 of the STCW Code as amended in 1995. It offers self-testing and assessment features that enable you to measure your knowledge and document your participation in your vessel's training, drilling, and assessment program. As you watch the videotape, keep in mind that your vessel may have additional policies and procedures that you must follow. Ships use a system of alarms to warn personnel that a fire emergency exists. The general alarm for fire and emergency sounds like this. Other alarms are triggered by installed fire detection and extinguishing systems. Each vessel has a variety of internal communication capabilities, including messengers, telephones, intercoms, radios, and public address systems that can be used to coordinate fire response efforts. To communicate with other vessels, the Coast Guard, or a shoreside fire department, the bridge uses a variety of external communication systems, including marine radios and telephones, as well as the ship's whistle and signal flags. Firefighting efforts are organized by the ship's fire control plan. Station bills and station cards establish the chain of command and assign emergency duties to each crew member. The master serves as officer in charge with overall command of the vessel. The on-scene leader serves as officer in charge at the fire scene.
Okay, let's get a couple guys backing up on this hose. Mike!
A hose team leader commands each hose team. The nozzle man directs the stream and chooses the stream pattern. The backup man helps to control nozzle reaction pressure and move the hose. Additional crew members perform duties as assigned. It is each individual's responsibility to follow the chain of command and observe fire safety procedures. All fire squad members must be equipped properly. Fire zones should remain clear. All personnel should be familiar with escape routes from living and workspaces. The fire control plan identifies primary and secondary escape routes from all regularly manned spaces aboard the vessel. Your duties are listed on your vessel's station bill and the station card in your stateroom. Study these documents and learn your responsibilities as soon as you come aboard. Ask your supervisors to explain anything you don't understand. Each vessel is required to stage periodic fire drills. These exercises are scheduled by the master and conducted by the mate or team leader. To be effective, fire drills should involve different locations, different scenarios, and different classes of fires. During familiarization training and drills, you'll learn the location of the firefighting appliances aboard your vessel and be given the chance to practice using escape routes from living and workspaces. Practice escaping with your eyes covered. In a real fire, you may be blinded and disoriented by smoke and debris. In a crisis, your ability to survive may be directly related to your familiarity with the vessel's escape routes and your understanding of fire travel and heat transfer. Everyone aboard your vessel, including passengers, must be instructed in methods of quickly reaching safety. A fire requires fuel to vaporize and burn, heat to raise the temperature of the vapor to its ignition point, and oxygen to combine with the fuel vapor. The mixture of heat, fuel, and oxygen is referred to as the fire triangle. A fourth component of fire, referred to as the chain reaction, combines with heat, fuel, and oxygen to form the fire tetrahedron. Remove any leg of the fire triangle or interrupt the chain reaction, and the fire will be extinguished. All matter exists in one of three physical states. Matter in each state can serve as the fuel for fire. Solid materials like wood, paper, and cloth are common sources of fuel. Vessels carry a wide variety of solid fuels, ranging from furnishings to cargo. Combustible metals, including magnesium, titanium, aluminum, and sodium, are dangerous solid fuels that may be carried as cargo. The burning rate of solids varies according to their configuration. Bulky fuels burn longer. Finely divided solids like dust or shavings burn faster because they present more surface area. Combustible and flammable liquids are another form of fuel. These materials are most commonly found aboard ship as bunker fuel, lubricating oil, diesel oil, and hydraulic fluid. Bulk liquid cargoes may also be classified as combustible or flammable liquids. Liquid fuels release vapors more readily than solids because they have less densely packed molecules. Pound for pound, liquids produce about 2.5 times more heat and liberate heat 3 to 10 times faster than wood. Combustible fuels have a flash point above 80 degrees Fahrenheit. Flammable fuels have a flash point of 80 degrees Fahrenheit or less. The flash point is the temperature at which the fuel is capable of being ignited. For example, the flash point of gasoline occurs at minus 45 degrees Fahrenheit, while lubricating oil has a flash point of 400 degrees Fahrenheit. Vapors produced by petroleum-based fuels are heavier than air and seek low places, dissipating slowly and traveling to distant ignition sources. Gases represent a dangerous form of fuel. Gases are always in a vapor state, ready to mix with oxygen and heat to cause ignition. Heat initiates the chemical reaction called combustion. It can be caused by the flame of a match, by sparks, by friction, or by electrical short circuits or electrical arcs. Heat sufficient to ignite a fire can also be produced by chemical reactions. Air normally contains 21% oxygen, 78% nitrogen, and 1% other gases. A minimum oxygen concentration of 16% is needed to support visible flaming combustion, although smoldering combustion can take place in lesser concentrations. The chain reaction starts when the burning vapor produces heat, which generates more vapor. This produces still more heat, vapor, and combustion until the process reaches its maximum rate and levels off, producing a steady burn. This chain reaction continues until most of the fuel is consumed. Fire safety is every seaman's constant responsibility, on watch or off. You must be capable of recognizing fire hazards and of practicing effective fire prevention. Smoking is an obvious hazard. If you smoke, make sure you do so only in designated areas and dispose of your butts and matches properly. Electricity is a common fire hazard. Never overload electric circuits or outlets. Inspect wire runs, cords, and electric tools regularly. Replace defective electrical components. Be alert to the danger posed by defective lighting. Static electricity also represents a fire hazard. On the deck of an oil tanker, for example, all electrical equipment must be intrinsically safe, and even common devices like cellular phones are prohibited. Engine rooms are filled with fire hazards. Repair or replace lagging and insulation as needed. Fix oil and fuel leaks and clean up spills. Maintain a clean engine room.
There's nothing more important than housekeeping. If you keep the engine room clean, well lighted, well painted, preventing any accumulation of any rags. Everything you've heard of and you think of as common sense. That's your primary firefighting.
Galley operations can create fire hazards. Practice good housekeeping. Mop up spills immediately. Clean range hoods and fan flues frequently. Dispose of paper garbage in designated receptacles. Don't spill cooking oils on stovetops or overheat cooking oils. Maintain electrical installations in safe condition. Be sure you know the location of electric disconnect switches. Practice fire prevention in your berthing area. Don't smoke in bed. Don't use unauthorized electric fittings or appliances. Don't empty ashtrays into trash cans without ensuring that all cigarette butts are out. Cargo areas can also present fire hazards. Practice good housekeeping. Ensure that cargo is properly stowed and secured. Observe no smoking warnings. Welding and cutting operations require hot work permits and the maintenance of a fire watch. Sloppy work habits increase the fire hazards associated with dangerous tasks like this. Fuel oil transfer and service operations must be conducted in accordance with federal rules designed to eliminate fire, toxic, and pollution hazards. Crew members aboard tankers, chemical carriers, and gas carriers must have specialized cargo handling and fire training. Spontaneous ignition occurs when heat and vapors build up in spaces that lack adequate ventilation. Poor housekeeping and careless work habits increase the fire hazards associated with shipboard operations. Conduction is the transfer of heat through a solid. It occurs when matter conveys heat without visible movement of the matter itself. Conduction is controlled by removing the fuel and cooling the burning material. Convection is the transfer of heat through the motion of heated liquids, gases, smoke, hot air, or flying embers. Heat traveling by convection moves both vertically and horizontally. It is controlled by setting fire boundaries. Radiation is heat transfer by electromagnetic or radiant energy propagation. It is the transfer of heat from a source across an intervening space when no material substance is involved. It occurs in a straight line of travel and is controlled by applying water fog as a shield. Class Alpha fires involve common combustible materials that produce an ash. Class Alpha materials include wood, paper, cloth, rubber, and most plastics. The most effective extinguishing agents for Class Alpha fires are water, foam, and dry chemical. A Class Bravo fire involves flammable or combustible liquids, gases, greases, and similar products. Class Bravo fires can be controlled by cutting off the supply of oxygen and vapors or by shutting off the fuel supply. Liquid Class Bravo fires are best extinguished with foam, halon, or carbon dioxide. Securing the fuel supply is the best means of extinguishing a gas fire. Class Charlie fires involve energized electrical and electronic equipment, conductors, or appliances. In extinguishing Class Charlie fires, the first priority is to protect firefighters from the electric shock hazard. Current to the affected area should be shut off at the source. Non-conducting agents such as carbon dioxide or halon are the best choices for these fires. Although dry chemical is effective on Class Charlie fire, it is also highly corrosive and damaging to equipment. Water must be used with extreme caution. Water can only be applied to a Class Charlie fire as wide fog with a minimum 4-foot standoff distance. A water stream should never be used. Class Delta fires involve combustible metals such as magnesium, sodium, phosphorus, titanium, and aluminum. The best method of extinguishing a Class Delta fire would be to jettison the fuel. Where jettison is impossible, special extinguishing agents called dry powders are used. Water is the most readily available extinguishing agent at sea. It breaks the fire triangle by absorbing tremendous amounts of heat. Water expands 1,700 times as it turns to steam and extinguishes fire by cooling and smothering. Its disadvantages as an extinguishing agent are the fact that it conducts electricity and represents a hazard to firefighters in Class Charlie fires. It is also corrosive and heavy. Foam extinguishes by vapor sealing, air exclusion, and cooling. It is produced in 3% and 6% solutions.
Foam is good for Class B fires. It's capable of putting the fires out by basically smothering the vapors or stopping the flammable liquid's ability to process vapors. The lob-in method is where you take the nozzle and you apply the foam in the air and let the blanket gently drop on top of the vapors. There's the bank-in method where you actually apply the foam solution prior to the spill area and let it move forward over top the spill. And the other one is the sweep method, or banking it off of some solid object and let it float down on top of the fuel vapor.
Carbon dioxide is most effective in a confined space. 1.5 times as heavy as air, it flows to the bottom of the space and breaks the fire triangle by displacing the oxygen and smothering the fire. It also expands 450 times in volume and drops to minus 110 degrees Fahrenheit. It is non-toxic and effective on Class Bravo and Charlie fires, but represents an asphyxiating hazard to personnel.
The way the CO2 extinguishes fires is by reducing the oxygen down below 15%. If you are in an enclosed atmosphere, you need that oxygen also to breathe.
Dry chemical extinguishing agents attack the chain reaction.
Dry chemical is good on Class Bravo and Class Charlie. Some of the dry chemical, if it is rated for A, it would be ABC dry chemical, is good on Class Alpha fires, but it doesn't have much reflash protection, so you would need to back that up with water or tear apart the Class A material.
Despite their effectiveness, however, dry chemical agents should be used as a last resort because they are highly abrasive and corrosive. Halon is a vaporizing liquid that produces a colorless, non-conducting gas that is 2.5 times more effective as an extinguishing agent than CO2.
Halon works by interrupting the chemical chain reaction on the fire. It has no cooling effect at all.
It is non-corrosive and the best agent to use in spaces that contain sensitive electronics or equipment. When fire prevention efforts fail, the speed with which the crew reacts is usually the difference between a catastrophe and a crisis averted. Small fires are easily extinguished, but fire grows exponentially over time. When fire breaks out, every second that elapses heightens the possibility of disaster. Fire detection is the critical first task.
Hey Dave, we got a fire in the crew berthing area, Class A. Nobody's in there. I'm securing the hatch. Get a hose team.
Installed fire detection systems include photoelectric and ionization smoke detectors, fixed temperature heat detectors, rate of rise heat detectors, and flame detectors. Automatic alarm systems utilize detection devices that are wired to local alarms and to remote receivers on the bridge. Where installed detection systems do not exist, fire patrols should be maintained as necessary to ensure that all vessel spaces are free from unsafe conditions. The patrol function is most critical after normal hours of operation or when normally manned spaces are vacant. If you discover a fire, sound the alarm. Immediately shout a warning or use a shipboard communication device. Make sure the message reaches the officer of the watch.
Land! Fire in the engine room!
Randy, what is it?
Fire in the engine room. Unable to put it out. Fire on the port main. Broken fuel line.
I'm gonna set the bill. Call the Coast Guard. You get everybody up.
Okay.
Give the bridge an accurate report about the location of the emergency,
Captain, this is Howard. We have a hot door at crew berthing.
what is burning, and any actions that have been taken to control the situation.
And we're breaking out the hose line at this time, preparing to attack the fire.
John, we got a fire. Come on.
Alert others who may be in danger. Help them escape. You may be able to extinguish a small fire with portable fire extinguishers, but don't try to be a hero. You'll only complicate the problem if you become a victim of the emergency. Confine the fire by closing doors and hatches. Prevent fire spread by shutting off ventilation systems and moving combustible materials away from adjacent bulkheads. Shut off fuel supplies and electric circuits that may be fueling the fire.
Bridge, second mate.
Throughout the emergency, a chain of communications must be maintained.
Roger that. Class A fire in the laundry room. I'll sound the alarm and call the captain.
From the emergency squad to the on-scene leader to the wheelhouse. Fixed fire extinguishing systems that attack fires indirectly are installed in high-hazard spaces like the engine room. Fixed systems work by flooding, smothering, inhibiting, or cooling the combustion. Fixed systems use a variety of extinguishing agents, including carbon dioxide, halon, foam, and water emitted by sprinkler heads. Other fixed firefighting appliances aboard the vessel include fire mains, hydrants, the international shore connection, emergency generators, fire and bilge pumps. Only authorized personnel are permitted to activate a fixed fire extinguishing system. The system should never be activated until the captain or mate gives the order. The atmospheres created by fixed fire extinguishing systems can become asphyxiating or toxic and extremely hazardous to personnel. All personnel must be evacuated from the space prior to triggering the system.
48Q men.
A complete crew muster must be taken to ensure that everyone has gotten out. Seal the space by securing access points, ventilation systems, and machinery. When the order to trigger the system has been issued, break the glass and pull the control valve or cylinder.
Releasing the carbon dioxide is a conscious thought. You've already fought the fire the best way you can. You can't do it anymore. You abandon the engine room and you manually release the carbon dioxide, which before it actually releases will shut down the ventilation, the boiler fans, the fuel oil pumps. All of that will stop automatically. And then you pull the boiler release, a siren sounds in the engine room for 15 seconds, and then the release is immediate, flooding is immediate. Hopefully the fire goes out immediately. But it's a one-shot fare. Once you release the carbon dioxide into the engine room, you've used everything you have. You don't have a second chance.
The vessel must be equipped with a sufficient number of fire hydrants, positioned so that any part of the vessel is accessible with overlapping water streams. Cargo holds must be reached with at least 2 streams of water from different outlets. One must be a single length of hose. Shut-off valves must serve each hose to facilitate their removal. The fire main must have isolation valves. The international shore connection is located on each side of the vessel. It is used to connect the ship's fire main system to shore-based firefighting equipment. The firefighter's outfit consists of the Nomex hood, turnout pants and boots, turnout coat, helmet, gloves, and eye protection. You're required to be capable of properly donning this gear in 3 minutes. Turnout gear is fabricated from heat-resistant material that offers protection at temperatures up to 1500 degrees Fahrenheit for short periods of time. The gear is lined and incorporates a vapor barrier. Pull the Nomex hood over your head. Ensure that the opening corresponds to your face area. Lay the bib portion flat on your shoulders. The Nomex hood goes over the head straps that secure a self-contained breathing apparatus. Pull on your turnout pants and boots. Ensure that your pant cuffs remain outside of the boot tops. Fasten the waist and front flap fasteners. Adjust the suspenders for a secure fit. Adjust the waist strap. As you put on the turnout coat, make sure that the hood bib lays flat on your shoulders. Fasten the front and neck snaps and make sure that the collar is turned up and closed.
Okay.
Adjust your helmet for proper fit. Pull down the ear flaps. Position the chin strap so it fits properly. Ensure that the gauntlets of your gloves are inside your sleeves. Helmet-mounted eye protection should be utilized when it's available. Goggles or glasses should be worn over the hood. The firefighter's outfit has advantages and disadvantages. It withstands direct flame impingement for short periods of time and protects the wearer from radiant heat, falling debris, and sparks. It is limited by its temperature rating, tends to induce heat stress injuries, and decreases mobility and dexterity.
The protection far outweighs any of the problems. I would much rather have the gear on and take the disadvantages than I would with trying to go into a hot, smoky environment without the gear. It is my best friend in there.
The Personal Alert Safety System, or PASS device, is a critical component of a self-contained breathing apparatus that is fitted with this feature. If you stop moving, it alerts others that you may be in trouble.
The wearer is motionless. It emits an alarm.
This PASS device is activated when you turn on the air bottle. It makes that initial noise when it comes on. The pressure gauge responds to the pressure, and the flashing green lights indicated that the PASS device is in use and ready to go. This tells the operator or the wearer that their device is ready to alert if they get a low alarm condition or low air pressure, or if they don't move for a given period of time.
Personal atmospheric meters enable you to monitor respiratory hazards. Flashlights are standard components of the firefighter's personal protective equipment. A lifeline is a crucial safety link for personnel entering hazardous spaces. For members of a hose team, the hose doubles as a lifeline.
There you go, Dave. Okay, thanks.
A lifeline can also serve as a communications tool.
Okay, are you okay?
One pull indicates that entry personnel are okay.
Advance! Okay, advancing.
Two pulls indicate they are advancing.
Take up slack. You're taking up slack.
Three pulls instruct exterior personnel to take up slack. Four or more pulls are a call for help.
Okay.
Firefighting appliances include the axe, the spanner wrench, and the knife. The gated Y permits a water source to be divided into two hose lines.
This is a 2.5 to 1.5 inch gated Y. This is used for connecting to a 2.5 plug or 2.5 hose line, so that you now can connect two 1.5 inch hoses to the 2.5, whether it be a plug or a hose line. And we have the ability to shut down the water flow at this point with the gates.
Reducers and adapters permit hose lines and fittings of different configurations to be used in combination. The all-purpose nozzle produces water as a solid stream or as wide fog.
This should be operated with the backhand coming up, pushing forward, or pulling back to the fog position, or solid stream.
Vari-tip nozzles can be adjusted from straight stream to wide fog by twisting the tip. While the vari-tip nozzle provides an infinitely adjustable discharge pattern, it is more likely than the all-purpose nozzle to be clogged by debris. The all-purpose nozzle can pass debris up to 1/4 inch in diameter through either the fog or stream tips. The applicator produces low-velocity fog. It can be fitted to the all-purpose nozzle after removal of the spud tip. The applicator is used for indirect firefighting. It can be inserted through a door or hatch to discharge low-velocity fog, or used to protect other personnel from radiant heat. The fixed deck monitor discharges large volumes of water. Prior to using a portable extinguisher, pull the pin and test the discharge to ensure that the device produces positive agent and to check its effective range. Aim at the base of the flames, squeeze the discharge handles, and apply the agent with a sweeping motion.
Okay, positive agent.
The 2.5-gallon water extinguisher is a stored pressure appliance with 35-foot range and 55-second duration.
This is a 2.5-gallon water extinguisher. It's pressurized simply with air. It has, the top is removed. It's filled with 2.5 gallons of just plain old water. Simply uses an air chuck, just like you would use on a tire, to fill it up to approximately 100 psi. It's simply activated by pulling the pin, aiming the nozzle, and squeezing. But it is a good extinguisher for small class alpha fires. It's a first aid for small fires, essentially.
Foam extinguishers are 2.5-gallon stored pressure appliances with 35-foot range and 55-second duration. Portable fire extinguishers must be inspected monthly and serviced annually according to the manufacturer's instructions.
The first thing is a visual inspection to make sure that there's no obvious dents, cracks, or breaks in it. Make sure that the hose is secured and tight, doesn't have any abrasions or frays in it. Make sure that the pin is in place and that the gauge reads in the green, which means that it's completely pressurized. Next, you want to make sure that the aerator nozzle is in place. This is the aerator feature on the nozzle here, and you want to make sure there's no obstructions in the tube. Foam is good for Class B fires. There's two main reasons you wouldn't want to use it on a Class C fire. The first being that the water that's used as the base of the foam solution conducts electricity, and the second that the water being applied to energized electrical equipment could damage it. With the wind at your back and with your face shield down, and you'll start a sweeping pattern roughly 6 to 8 feet away from the base of the fire.
Dry chemical extinguishers come in 2 to 30-pound sizes. They have ranges from 10 to 30 feet and discharge durations of 8 to 30 seconds, depending on size.
This is a cartridge-operated dry chemical extinguisher. It is filled with 18 pounds of dry chemical. This happens to be regular dry chemical. It could be ABC dry chemical, could be Purple K. It has a cartridge that is filled with CO2 to activate it. We want to make sure that the cap is on snug. This normally would have a band on it sealing it. We would bring the handle up, breaking the band. We would gain control of the extinguisher. You control the nozzle so that if this charges with the nozzle in the open position, it doesn't fly up and hit you in the face. You want to double check and make sure the cap is tight, and then you would strike the plunger with this aimed away from you or anyone else, so if this cap came off, it wouldn't injure someone.
Dry chemical extinguishers carried aboard ship should be shaken frequently to prevent the agent from caking on the bottom of the container. A standard carbon dioxide extinguisher holds 15 pounds of agent in a cylinder weighing approximately 45 pounds. These devices feature a range of 6 to 8 feet with typical discharge durations of 45 seconds. CO2 extinguishers lose effectiveness in exterior spaces where the agent is dispersed by the wind. Carbon dioxide gas also represents an asphyxiating hazard to personnel.
This is a 15-pound CO2 extinguisher. It's real good on Class Charlie fires, energized electrical fires, and small Class Bravo fires. Now, when you're flowing this, it also creates a static electrical charge. So prior to extinguishing the fire, you need to ground the extinguisher, whether putting it onto the deck or up on the bulkhead. The tag on the extinguisher indicates when the extinguisher was serviced last. Every extinguisher needs to be serviced once a year.
Halon extinguishers vary in size from 2 to 12 pounds, and the effective range varies from 9 to 15 feet. Halon is an extremely effective extinguishing agent, but provides little cooling, so the possibility of reflash remains high.
Make sure that your gauge is in the green, saying that you've got good pressure in here, saying it hasn't been used. In order to get this into operation, you go then pull the pin, break the seal. You want to give it a test to the ground before you start attacking the fire, making sure that you've got good agent. If I'm out on weather, I'm going to have the weather to my back. If I'm in an enclosed area, I'm going to make sure that I have an exit to my back. When I'm attacking a Class Charlie fire, first and foremost is I want to make sure that the power is secured by a remote source. Then I can go in there safely and attack the fire. Never turn your back on a fire. You're always back away from it in case it does reignite.
The self-contained breathing apparatus, or SCBA, is an essential tool for coping with hostile or unknown atmospheres.
You're looking at a self-contained breathing apparatus manufactured by Scott Manufacturing. This is a high-pressure system, 4,500 psi, which consists of a cylinder and 7 major components. 7 major components are the cylinder gauge, the step-down regulator, the backpack assembly, which consists of the shoulder harnesses and the waist harnesses, the wearer user low-pressure alarm, the wearer user gauge, and the mask-mounted regulator. Air leaves the high-pressure system, follows the line to the first stage regulator. From the first stage regulator point, it gets stepped down to slightly higher than atmospheric pressure, follows this tube to the low air warning alarm, which is mounted directly on the wearer's shoulder harness, follows the hose through and into the second stage regulator. The second stage regulator takes the air and allows the wearer to use it and consistently keep slightly higher than atmospheric pressure within the facepiece assembly.
Well, you want a constant supply of air so that way in a hostile environment, the smoke, the toxic gases and so forth, you've got the ability to breathe fresh air and maintain a positive pressure within the facepiece so none of the gases can get around the facepiece and into your respiratory system. Yeah, this valve here is that provides your air into your regulator system. When you operate it, you want to open it fully. This is the mechanical low alarm. You can hear it on initial turning of the valve. The bell will sound there.
The bypass valve is mounted on the side of the regulator in case there's some kind of malfunction in the second stage regulator. It allows air to go directly from the first stage regulator into the facepiece assembly.
This device here, which is on both of these, is a standby strap, which allows this to go over the firefighter's head and suspend the mask when it's not in use.
Seamen should strive to be capable of donning an SCBA in 60 seconds. You should be familiar with each of the following donning methods: off the wall, partner assist, coat swing, and over the head. You must be capable of changing your partner's oxygen bottle even if you're wearing your turnout gear.
That's a full bottle, right?
It's a full bottle. Okay. 2200. Okay, the bell just rang. You're set.
Okay, my gauge says I'm full, I'm off.
And know how to perform emergency breathing in conjunction with a partner.
If there's a malfunction in the user's facepiece, or if the bottle is completely dry of air, another member can come up and quick connect into this Schrader fitting and pump air back into the facepiece. This doesn't fill the bottle with air. What it does, it allows the user to breathe from another air supply.
There are two strategies for controlling a fire. Defensive firefighting seeks to confine the fire. It is accomplished by sealing the space, removing the fuel, and setting fire boundaries. The burning compartment must be completely isolated by closing doors and hatches and shutting down mechanical, electrical, and ventilation systems. Fire boundaries must be established on 6 sides of the compartment by removing adjacent sources of fuel and cooling perimeter bulkheads. The objective of offensive firefighting is extinguishment. It is accomplished by applying extinguishing agent onto the fire, either as a direct or indirect attack.
Hold them and carry on. Okay, good agent.
Okay, let's go.
As hose team leader, you must be capable of selecting proper nozzle settings. Use a straight stream to penetrate and break up Class Alpha material. Use wide fog as a shield for protection against radiant heat.
Door's hot. Okay, cool the door down.
You must also be capable of safely advancing the hose line. Approach the fire from upwind. Crouch low and maintain a clear exit path.
Hey, check for pressure, Dave. Blast off?
Blast off!
No pressure?
No pressure.
Okay. Go ahead and hook up your face piece.
Fire.
Okay, Skipper, we are on air, about to open the door. Go ahead and open the door, Dave. See no fire at the door? Are you ready, John? Go ahead and take the hose line in. Let me know what you've got.
Use a circular motion to apply the agent in an indirect attack, starting at the overhead. Discharge the water into the thermal layer above the combustion so it flashes to steam and drops down onto the flames. Complete the attack by applying water directly onto the seat of the fire. Where possible, jettison burning material or sources of fuel.
Advance!
Rescuing personnel from hazardous environments requires the use of an SCBA and safety line. Search the space thoroughly, using an organized pattern. In drills, you will have the opportunity to practice using a life-size mannequin. When the fire is out, ventilate the space. Water fog can be used for active desmoking.
Skipper, this is Howard. Fires are knocked down. We need to overhaul.
Set the reflash watch. Search for hidden fires, hot metals, and smoldering combustion. Overhaul the fire by removing all burned materials and cooling and cleaning the space.